Okay, to illustrate the importance of the grade of fasteners, so let's say you and this friend have this crazy idea, and just work with me. You're trying to pick up this load of 3,800 pounds. You've got to pick it up, and for some reason you've decided to do it by taking a lift and having a fastener, attaching a piece to it that would then attach to the lift, attaching a piece to it that when attached to the load. Again, just work with me. I'm using this to show you the strength of the fastener, why it matters. And so you're going to lift this up, so the fastener has to support the 3,800 pounds. So you say, oh yeah, I remember all that. I'm going to get a grade 8 fastener. So you look, and the minimum tensile strength for grade 8 is 150,000 pounds per square inch. So what that means is 150,000, that's the tensile, that's what the minimum they guarantee it'll hold, equals the force over the area. So the force that it'll hold is 150,000 times the area. So 150,000 times 0.031 square inches. And you say, wait a minute. If I take a 1/4 inch and say pi r squared, I don't get 0.031. No, you don't. There is a special standard called tensile strength area that's used when you're calculating ultimate force with fasteners, and it's based upon the thread because the thread is narrower. So a 1/4 20 and a 1/4 28 have different areas. But if we do that, so we get the force that this will hold based upon the ultimate for a grade 8 1/4 20 bolt will hold 4,650 pounds at least, which is greater than the 3,800 that we need, so everything should be good. So let's give it a try. I'm going to go down to the tensile tester, take a grade 8, pull and break it, and let's see whether we drop the load or not. So here's the setup. We've got the fastener with the 2 blocks on it, and we're going to put it in the machine. As the tensile tester stretches the part as it pulls, you're going to see this graph. This is going to show you the force, how much it's pulling on the left, and then across the bottom is going to be displacement, how much it's stretching. So this is a grade 8. You can see the head. The test starts. You see the graph going up the red. On the force, the left, it's pulling. The displacement's on the right. It's continuing in. It passes yield, ultimate, and then it breaks. So notice the part broke in the threads. That's what we would expect with a fastener. That's the weakest point. Now look at the graph. This area in here, that's the elastic range. And so you can see how much we're stretching, like that's 0.08. If we had let go during this time and released the force, the fastener would have gone back. What that's saying is this fastener had stretched 0.08 of an inch. That's the elastic zone. Somewhere in here is the yield. We passed the yield. Right there, the ultimate. This hump that you see right here, what's happening is after yield, the part is starting to neck. It's starting to narrow, and then wham, it breaks. The ultimate was about 5,700, somewhere in there. That's greater than our 3,800. So the math works. Wonderful. We didn't drop the part. Everybody's happy. But that's really not what happened, because you see, when my friend came back, he couldn't get a grade 8. So instead, he got a grade 2. The problem was he didn't tell me. Now, so look what's going to happen. The minimum tensile strength for a grade 2 is 74,000. If I do the same math, it'll hold the ultimate 2,294. At least it'll hold that. We may get lucky and it holds enough. That's less than our 3,800, so it doesn't sound like it's going to work well. So let's break a grade 2 and see what happens there. So now we've got a grade 2. You can see the head. The graph of the grade 8, it's already on there. Here comes the 2. Starting out strong, but look how quick it goes. And bam, it breaks. You can see it broke at the threads just like before. And the maximum looks to me like about 3,600, which is good. It's a lot better than the minimum that it had to be of the 2,294, but it's still less than the 3,800. Because the guy got the wrong one, we dropped it and it was a mess. So you see, the grade of the fastener really does make a big difference, as we can see in this simple case with a 1/4 20, between a grade 8, which had an ultimate of 5,800 and a grade 2 3,600. Both of them over what was calculated, but that's to be expected because that calculated is a minimum. They have to make sure that it's above that for it to be that standard. Now, one thing I want to point out though, this was just an example showing you the difference between the fasteners and the strength. So we calculated the ultimate. That's where it's going to break. That's not how you design. You don't design for where something will break. So we compared 3,800 pounds to that and said we're fine. That's not how you would really do it. The yield point, the chart tells us is 130, so that means it's going to yield at 4,000, so we're pretty close to the yield. The proof load, it tells us is 120, so 3720 is the proof load. So you see we're above the proof load, and then the typical working load where we want is down in here. So you see, if we were designing this, if we weren't two crazy friends out doing something, we would not put 3,800 pounds on this fastener. We would want to stay in this range in here, again, around 37 or 3,000 pounds if you want to round that. So I just wanted to point out this example is just showing you the big difference in these fasteners, not how you would design, because we designed for it to break.